Good morning. Welcome to today's webinar, Palo Alto Networks and Big Switch Networks, Securing Applications and Data within Next-Gen Data Center Networks. My name is Bala Ramachandran. I am the Director of Product Management at Big Switch, and I will be your host for today's webinar. Joining me today are Sai Balabhadrapatruni, Senior Product Marketing Manager at Palo Alto Networks. Welcome, Sai. Ganapati Bhatt, Principal Technical Marketing Engineer, Big Switch Networks. Welcome, Ganapati.
Thanks, Bala.
And Arkady Shapiro, Principal Technical Marketing Engineer at Big Switch Networks. Welcome, Arkady.
Great to be here. Thank you.
As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or your questions on a particular upcoming webinar topic that you would like our panelists to address, just go to bigswitch.com/webinars and submit a question using the link provided. We have also provided you with handouts for today's session. You can download them from the handouts tab on your dashboard. We have a full agenda for today's webinar, so let's get started. So our first speaker will be Sai. He'll present Palo Alto Networks Next Generation Firewall, and will also highlight the joint value of Palo Alto Networks Firewall when deployed with Big Switch's Big Cloud Fabric. He'll then be followed by Arkady, who will discuss the unique benefits of BCF and the Palo Alto Networks Next-Gen Firewall deployments for VMware environment. He'll follow that with a demo. Ganapati will then take us through the details of BCF's P+P OpenStack solution with Palo Alto Networks Next, offering tenant-level security for OpenStack deployments, and he'll also show a demo of the solution. Finally, we'll have a Q&A. So a lot of good content to go through today, so let's get started. But before I hand it over to Sai, let me start off with a quick overview of the key trends that are driving this data center solution. So hyperscalers have led the innovation in networking for the past decade. They've built their own solution with software running on commodity hardware instead of using proprietary networking products. So this fundamental shift into software has helped them accelerate speed of application deployment, enable management simplicity, all at a much lower total cost of ownership. Big Switch's products such as Big Cloud Fabric are essentially leveraging these same principles to offer ready-to-deploy solutions for the mainstream data center. Solutions that can be deployed at enterprises and service providers and offer tremendous operational value in terms of 4x speed of app deployment, 16x faster config and upgrades, 12x faster troubleshooting, and of course 40% overall TCO savings. Now, if you take a step back and look at the world of compute, we saw how the mainframe, a proprietary stack, got disaggregated with the x86 architecture, which has led to faster, simpler cycles of development and deployment for applications, and has offered vendor choice and also enabled a vibrant innovation across the stack. Now, with the advent of two key trends, software-defined networking and open networking, we are seeing the same thing happen with the networking industry. So the proprietary stack, which is based on traditional chassis, which we call as the net frame, is now getting disaggregated and enabling choice and innovation at every layer, the ASIC, hardware, and software. So leveraging this fundamental industry transformation, Big Switch has created a scale-out leaf-spine cloud fabric product called Big Cloud Fabric, with a design that lends itself to operational simplicity, automation, while simultaneously being economical. So as we go through this webinar, we will dive deeper into the benefits of this next-gen fabric with Palo Alto Networks Next Generation Firewall, and we'll talk about it in the context of both VMware and OpenStack environments. So with that, let me turn it over to Sai.
Thanks, Bala. Appreciate that. Hello, everybody. Welcome to this particular webinar. And as Bala mentioned, there has been a significant transformation happening within data centers. And of course, Palo Alto Networks, with its next generation security platform, is actively working with Big Switch Networks to integrate our security into the big cloud fabric. So with that said, I just want to quickly touch upon a couple of topics before we go and talk about the integration details. One is the threat landscape, which is emerging in recent times, and how it is impacting data center deployments, and also touch upon some of the challenges which we are addressing with this solution where Palo Alto Networks next generation security platform works in conjunction with Big Switch's fabric controller. One of the key challenges most of the security practitioners face today is how to manage risk within their data centers. Now, this has especially become a challenging effort with the emergence of public, private, and of course, SaaS clouds. With this decentralization approach where applications and data are moving in three directions, what we are seeing today is this challenge of enforcing seamless and uniform security posture across all of this footprint which an enterprise or an organization has from their data center perspective. At the same time, we are also seeing a rise in the sophistication as well as volume of the kind of cyber attacks which most of the organizations are facing. And this, of course, directly impacts the risk posture which you want to really handle for your organization as the data moves around across all these areas. So let's kind of take a look at the kind of breaches and the volume of breaches which we have sort of experienced in recent times. If you pick up the newspaper, or if you basically look on internet in recent times, we are constantly sort of seeing a range of data breaches which are happening across the world. Some of them are listed out here, and also in recent times you've heard of the Yahoo breach too. The challenge out here really is the sophistication as well as the high volume of these attacks has gone up in an exponential fashion over the last few years. Talking about sophistication, I really want to spend a little bit of time going into details about the kind of attacks which a data center for an enterprise really experiences on a day-to-day basis. Now, I'll take a specific example and kind of walk through that particular attack so it gives some context in terms of the relevance of advanced security for your data center. So with that said, let me talk a little bit about a particular attack which happened back in 2012. This attack is attributed to an advanced persistent threat group codenamed Hidden Links. The Hidden Links, of course, is a hacker group which has been active for more than 6 to 7 years now, and their primary focus is targeting large institutions such as government, financials, utilities, healthcare organizations, and of course steal sensitive data and be able to sort of monetize on top of it in the dark web. Now, they were running a specific campaign back in 2011 and 2012 where they were targeting a large number of organizations here in America, especially from healthcare and financial world. As they were running these attack campaigns against these organizations, they started running into a challenge. They started running into a security technology made by Bit9, which essentially gives the ability to whitelist apps within your data center, and it was proving to be quite cumbersome for this attacker group to be able to penetrate into the data center. So they decided to pivot and focus in getting access to Bit9's data center technology so that they could compromise their original target institutions indirectly through Bit9. So in 2012, early 2012, they mounted an attack campaign against Bit9's data center, and I'll kind of walk through how they attacked this particular data center and what were the different tools and technologies they leveraged, as well as the different phases in this attack process. The first step, of course, what they did was they used advanced SQL injection as a mechanism to be able to get a foothold on the web-facing servers of Bit9's data center. And once they gained that foothold, they were able to install a specialized rootkit called backdoor.hykit, which essentially gave them the ability to scan and actually do a reconnaissance of the data center assets within Bit9's data center. And of course also gave them a foothold whereby they could launch further attacks within the data center itself. Once they had that foothold and once they were able to do that reconnaissance, they then attempted credential thefts across multiple levels or multiple segments within the data center, and were able to laterally move until they were able to zero in on their target servers, which essentially carried the digital certificates which were being leveraged to do the whitelisting functionality for their customers. Once they gained access to that particular certificate server, they were able to sign and of course exfiltrate those certificates and use those certificates to whitelist their attack tools which they were leveraging in their original campaigns. Thereby, they were able to go ahead and compromise some of the original organizations which they were focusing on by installing their malware, which was considered as a legitimate application by Bit9's technology, and were able to sort of penetrate those organizations. The key takeaway out here is the attackers now have sophisticated tools, and also they are figuring out a multi-phased approach of compromising your data centers. So the traditional approach of a perimeter-centric security strategy is not sufficient to address the challenges which you see within data center. So with that said, is there a pattern to this approach? Is there some commonality to this attack and the rest of the attacks and data breaches which we have been seeing in recent times? And the answer to that question is yes, there is. To a large extent, if you look at any kind of data center breach, you will see a very similar path which is taken by the cyber attackers in trying to gain access to sensitive data and be able to steal that data. In general, they are always trying to figure out the least secure attack vector and be able to focus on that and gain that foothold within the data center, then laterally move within the data center, and once they're able to identify the location of that sensitive data, then exfiltrate that data out of the data center. And the initial foothold could be through the perimeter. It could be through other access methods which are actually accessing your data center, through your mobile devices which are essentially accessing your data center, through partner networks which are connecting to your data center, through branch and remote offices which are connecting to your data center. It could be, the mechanisms could be a spear phishing email targeting your organization's employees. It could be sophisticated exploit kits which are getting installed into your network. It could be drive-by malware, which is also being used in a targeted fashion against employees within your organization. So in general, this pattern gets repeated, albeit with different set of tools being leveraged at each and every phase. Now, given that there is a pattern to this, and this threat landscape, of course, is evolving constantly and it's getting more sophisticated and sophisticated, what are the, outside of this particular challenge, what are the other challenges which you start seeing when you start looking at implementing a uniform security posture within your data center? Some of the key other challenges which we see when it comes to data center deployments are, one is the lack of visibility. This kind of directly ties into that reconnaissance which we talked about earlier. As you can imagine, if the attacker is blind and is doing reconnaissance within your data center, you should absolutely be one step ahead of them by making sure that you have pervasive visibility across your data center. And the other one is, of course, manual security operations. And this has been the biggest challenge for a long time, where security has not really kept pace with the evolution and the changes which are happening within data centers. More agility, the ability to, the flexibility and the on-demand scale, which essentially data centers are embracing today, security has not necessarily kept pace with that. And automation essentially is a key element to help you gain that edge in conjunction with your workloads. The third and final one, of course, really ties into having a very holistic security posture across your network. You really want to make sure that all the security controls which you are enforcing within your data center are very similar to the ones which you are enforcing at the edge of your data center, as well as within any public cloud, as well as SaaS cloud environments where you have a footprint from an organization standpoint. So the threat landscape, along with these three challenges, really form the basis for Palo Alto Networks' next generation security platform. We essentially have looked at addressing these four big challenges with our platform, and our solution with Big Switch really helps you in achieving that outcome in a rapid and quick fashion. So with that said, let me just give you a very quick overview of what Palo Alto Networks is and what do we do within the security market space. So Palo Alto Networks is a 5-time Gartner Magic Quadrant leader. As you can see out here, we are considered as the vendor with the highest, the top rightmost corner, where we are considered to be highest in execution as well as being a visionary. We have consistently delivered technologies, security technologies, and prevention-focused security architectures, which help you in securing your networks, whether they are at the branch, whether they are at the edge, whether the mobile networks or your data center, as well as your public cloud and SaaS environments in a very uniform fashion. So our security platform extends the same security posture across any footprint which you have as an organization. Coming to our data center security portfolio, I quickly wanted to give a short overview of what our product portfolio really looks like and what are the platforms which are integrating with Big Switch Networks, Big Cloud Fabric. So on the virtual side, we have VM-Series, which essentially is our virtualized next generation firewall. It runs the same software which runs on our physical appliances. It's actually managed, in fact, both physical and virtual appliances are all managed by the same management platform, which is called as Panorama. We also have a 3000 PA 3000 series, PA 5000 series, and a PA 7000 series as our physical appliances, which kind of fit together. Now, the key thing to note out here is the performance envelope is the key distinguishing factor across all these appliances. The 7000 series, of course, is a chassis-based appliance. So the virtual editions integrate with virtualized data centers, and of course, physical appliances sit both in the core as well as edge of your data centers. So what integration or what is the joint integration which has been done with Big Switch, Big Cloud Fabric? The key things to note out here is both our virtual and physical appliances integrate with Big Cloud Fabric, and you will see both Arkady and Ganapati show demos to showcase that. The three main components within our integration really are from the Palo Alto Networks side, we have the physical or the virtual appliances. And of course, our management platform, Panorama, which essentially is the single pane of glass where you go ahead and enforce the security policies which apply across your data center. And of course, we seamlessly integrate into Big Cloud Fabric. The three key benefits to focus on really from our perspective with this joint integration are, one is security service insertion. The challenge has always been that once you have a security appliance or, for example, a firewall inserted into your data center fabric, it essentially becomes a case of rerouting all your workload traffic towards the firewall to get that deep inspection. Now, with this integration, this is done dynamically for you without necessarily using any proprietary protocols. This is exactly the value proposition of the big cloud fabric, and we seamlessly integrate into that. Microsegmentation, especially on your underlay networks, is the other aspect which you can look into, and that is essentially the ability to segment your physical workloads from your virtual workloads or other physical workloads by leveraging our physical appliance. And finally, with our advanced threat protections, you have the ability to protect your applications and data from known and unknown malware. So that's the key elements of our integration. What are some of the typical customer use cases where you will see the joint integration leveraged? I have listed 3 of them. The first key one, of course, is to be able to gain visibility and control into east-west traffic. You have the ability now to identify, log, and safely enable applications across your data center, physical as well as virtual. Advanced threat protection, I already talked about it. You have the ability now to protect your applications and data from known and unknown cyber threats. And finally, if you have multi-tenant deployments within your data centers, now you have the ability to securely enforce security controls across different tenants within your data center. And these tenants, of course, with an enterprise could be different departments, but you have the ability to isolate traffic, log traffic, and of course, enforce separate policies for each and every tenant. So with that said, I just want to sort of quickly summarize some of the key takeaways out here. With this joint solution between Big Switch and Palo Alto Networks, now you have the ability to gain pervasive visibility and control within the data center. You also have the ability to seamlessly have security service inserted as and when needed across your physical workloads as well as virtual workloads. Advanced threat protection, of course, is something which we bring to your data center and also protect you from any kind of lateral movement or, for that matter, known and unknown malware. And finally, you can safely go ahead and secure your multi-tenant deployments within your data centers. Let me go ahead and hand it over to Arkady, and Arkady is going to go and walk through the different ways we integrate with VMware. Arkady, go ahead.
Out Thank you so much, Sai. Let me switch over the slide. Okay, excellent. So my name is Arkady HYPERSCALE, Technical Marketing here at Big Switch Networks. So I'm excited to talk to you about the Big Cloud Fabric VMware solution with Palo Alto Networks next generation firewall. So before we dive in, quick background on the Big Cloud Fabric for those who are maybe a little bit newer. Big Cloud Fabric brings cost savings, network agility, and other benefits of virtualization to data centers through a controller-based software-defined networking fabric. The product is based on leaf-spine architecture with open networking hardware running switch-lite operating system. It's purpose-built to optimize VMware deployments in the data center. Big Cloud Fabric integration with VMware simplifies the interaction between network and virtualization teams to help expedite the provisioning and troubleshooting of virtualized workloads. And our distributed logical router with fabric-wide service insertion policies, as well as the layer 2 or layer 3 equal cost multipathing, really help us optimize the deployment together with Palo Alto Networks. Now, how do we do this service insertion? Now, Big Cloud Fabric has a remarkably simple but yet powerful service insertion architecture that allows us to integrate L47 services with any variety of virtualized or bare metal workloads running on top of our fabric. Let's see how it works. So here we have 2 workloads in different segments, 2 virtual machines, for example. Without service insertion, essentially, traffic between the 2 workloads will be routed at the fabric. Whenever we implement the service insertion, traffic coming in from VM A would go to a logical router on the fabric. This is, again, distributed logical router. And it would get redirected to a service, right? And you can configure one or more services such as firewalls or load balancers or any type of devices that you want to redirect traffic to for analysis, inspection, enforcement, and things like that. Now, once the traffic has been inspected, it comes back to the fabric. And then, of course, the fabric routes it to the destination segment. Okay? And this is inspection assuming that the traffic was not blocked by the fabric. If it was blocked, of course, it wouldn't come back to the fabric. And so very easy, very simple, allows us to redirect traffic to the services, allows us to block traffic and do all kinds of things fabric-wide. Now, starting off with our VSPHERE solution, logical topology that we'll talk about today. In 2 segments connected to a logical router in the fabric, and then the traffic redirection is done to a Palo Alto virtualized firewall. So here we're using a VM that's running the same Palo Alto PAN-OS. And we're trying to do service insertion here, and the VM is doing that type of inspection. Right? The fabric configuration is managed, again, by the Big Cloud Fabric controller, and through our integration with VMware vCenter, with VMware vSphere, we do a lot of automation on the fabric. Now, in terms of physical setup, essentially we have a couple of ESX hosts, and I have virtual machines sitting in different segments, right, connected to different port groups on the VMware distributed virtual switch. And there's a Palo Alto virtual firewall that's sitting on another host, actually connected to a different rack in the fabric. And as I said, right, through our automation and through our single configuration of fabric-wide policy, we're able to redirect the traffic regardless of where the workloads are and regardless of where the Palo Alto VM is sitting in the fabric. Now, what are the benefits of this type of approach, of this solution, as compared to traditional networks that a lot of you may be used to? So first of all, starting with attaching an ESXi host to the fabric. Typically, you would have a lot of manual configuration. Right? So when you would connect an ESXi host, you have to configure MLAG, right? Whether you're using any of the typical vendor MLAG type of technologies, right? A lot of manual configuration, and even if you're a great configurator, even if you're a network expert, it's just error-prone, right? It's error-prone because it takes time, and when the network scales, you're bound to have errors. And typically, people say that, no, I can have scripts and I can have templates, and they can only help so far, right? Typically, those things are bolted-on solutions. They're not part of some integrated framework. With Big Cloud Fabric, through our integration with vSphere, this is really automated. Once you attach the ESXi host, we automatically configure a lag or MLAG on the fabric, so that really there's no worry about is the fabric configured properly. Now, layer 2 segments, whether those layer 2 segments are for compute, right, for those particular VMs, or actually the layer 2 segments that are inside segments for a firewall, right, the data segment for a firewall, or perhaps a segment that we need on the fabric to have the high availability between the two Palo Alto firewalls. All of this has been provisioned automatically, right? Once I have the port group configured on the vSphere, the fabric gets configured automatically. If the port group gets deleted, the fabric gets cleaned up. It's that easy. Layer 3 gateway. Now, we talked about service insertion happening at the layer 3 gateway. Typically, it has to be configured on multiple boxes, and even if a traditional vendor would try to make it easier, it's typically done using bolted-on templates or some sort of bolted-on management system. With us, really, it's one-time configuration across the fabric, and the reason that it's done is because of the controller-based architecture and the controller really seeing or having the entire view of the fabric. Now, policy redirection, right? Configuring the policy, whether that policy would drop the traffic or redirect it to the firewall for additional inspection. Typical what you see out there is complex box-by-box configuration of something like a policy-based routing. With Big Cloud Fabric, really, you configure a policy one time. It gets applied to the entire fabric, regardless of where the VMs, where the workloads are sitting, and where the virtualized firewall is sitting. Right? So, and if you're adding more and more virtualized firewalls, typically, the policy will take effect as well. And finally, troubleshooting. Right? Instead of a box-by-box troubleshooting, doing things like ping, trace route, checking routing tables, and anything that you may be used to, really we have a solution centralized from a controller called Fabric Test Path, which we'll see in the upcoming demo. Now, I talked quite a bit about the solution with vSphere, and I know a lot of you may be asking, well, what about NSX, right? There's a lot of talk about NSX, and what does Big Cloud Fabric do with Palo Alto Network in conjunction with VMware NSX? So we've already had a great solution as a physical underlay for NSX for quite some time, but at the last VMworld, we've announced a technical preview of our hardware VTAP solution. And in this particular example, where this can apply is if you have a virtualized workload sitting on the NSX overlay, right, behind the NSX VTAPs, perhaps they may want to communicate with a bare metal host that's on a different segment. And when that communication happens across segments, right, between NSX VNI and a segment for that bare metal host, we want that communication to be expected by a physical Palo Alto firewall. So in this case, given our hardware VTAP solution, the fabric will do service insertion and redirection to the Palo Alto Networks firewall. When the traffic comes back to the fabric, again, if it was inspected by the firewall and it was admitted, it was permitted to go through, it will get routed back to the bare metal host. So that's in terms of the logical topology, and physical topology, pretty clear here, right? You have a couple of hosts connected on the one rack on the Big Cloud Fabric. And then there's the Palo Alto Networks connected to another fabric. As I said, as we've seen before, regardless of where the hosts are connected with the VMs, regardless of where Palo Alto Networks is connected, we can have a seamless hardware VTAP that's fabric-wide. Right? Instead of having to configure hardware VTAP on multiple individual switches, we configure hardware VTAP for entire fabric. Right? And then the policy for service insertion again happens fabric-wide. Okay. Now, if a picture is worth 1,000 words, then a video is probably worth 1,000,000 words. So with that, let's jump into a demo. But before we jump in, so what we're going to talk about, the things that we just discussed before, the automatic ESXi host attachment, the automatic layer 2 network creation for VMs, right, whether these are the compute VMs or the Palo Alto Networks VM, service insertion using policies, and also configuration for Palo Alto Networks, and finally troubleshooting with the Big Cloud Fabric test path feature. So let me kick off the demo. We have two vCenter hosts, and in this vCenter host I have two VMs, one CentOS 1 sitting in one segment, and then Ubuntu 1 sitting in another segment. You also have a Palo Alto virtualized firewall that's configured on another host, and there is a data segment configured. Two VMs are actually communicating right now because there's no policy for any redirection to a firewall, so the communication is done through the fabric. And the reason that this communication is working is because we have connected to vCenter, we have actually provisioned the fabric. Here we can see the interface groups, which are essentially the link aggregation groups facing the host. And here we'll see the actual member interfaces. The compute segments that have been provisioned as well for the compute app and compute web. And also the two segments for Palo Alto Firewall, one segment for the data traffic, the Palo Alto Firewall inside, and one segment for the HA. On the tenant, we'll have a place to apply the policy, and we've pre-configured the policy actually here to deliver traffic to the Palo Alto Networks. And then whenever the traffic comes back from Palo Alto Networks Firewall, we essentially permit it to follow normal routing path in the fabric. Okay. So with that, we actually try to apply the policy. And once we apply the policy, we'll see that the traffic from Ubuntu 1 to CentOS 1 is actually working, but the other way, from CentOS 1 to Ubuntu, is not working. And of course, we may want to know why, right? Maybe the firewall is inspecting traffic and preventing it from flowing. So we'll take a look first. Maybe it's really the Big Cloud Fabric. Right? We'll see that the Big Cloud Fabric is actually permitting the traffic, and the traffic is going towards the Palo Alto Firewall. On the Palo Alto, we'll see that this traffic is actually being dropped. Right? So that any traffic here from particular source is being dropped. We'll try to allow the traffic, and once we allow the traffic flows through. Right? So really, we saw that in this demo, how we use in test path to troubleshoot, because it's quite possible that the policy on the Big Cloud Fabric can be blocking the traffic as well. We've seen that the Big Cloud Fabric is operating normally. Now we know where to actually go to troubleshoot further. So we've seen that the Palo Alto Networks Firewall is blocking the traffic, and we've seen, we've enabled the traffic flow through configuration of on Palo Alto, and also configuration of policies on the Big Cloud Fabric in a very seamless fashion. Okay, and that concludes the demo. Thank you very much.
Thank you, Arkady. Now let's move on to the OpenStack use case. Ganapati, over to you.
Let's switch gear a little bit to look at the Open Cloud solution we have from Switch and Palo Alto Networks. Yeah, again, all of you know the OpenStack, the promise, right? Is essentially to provide a self-service model to application deployment. Essentially, what we are going to talk and show is how our joint solution brings in that self-service model for a tenant for providing the layers 4 to 7 service insertion, and also the layers 2 and 3 networking using Big Cloud Fabric. So before going into the demo, I'll just walk you through the solution we plan to use. We plan to use Big Cloud Fabric P+V edition and Palo Alto Networks Next Generation Firewall VM series. So we already saw Big Cloud Fabric P-only solution with VMware, just we demonstrated that as well. With the P+V, we also provide the switch light virtual, which is essentially a virtual switch running on OpenStack cluster. It's essentially a user space agent running on all the Nova nodes. Let me call out some of the key benefits of P+V before going into the layer 4 to 7 service insertion demo. First thing is operational simplicity we bring in through single pane of management for both physical and virtual networking. Then let me call out the second one, the fabric config automation, essentially through our Neutron integration. Whenever tenant deploys the application, essentially network router gets created on the OpenStack dashboard. We dynamically provision that on the big cloud fabric. And the third benefit is data path optimization. Essentially, using our Neutron integration and the virtual switch, we provide the distributed logical routing as well as the distributed floating IP NAT for OpenStack workloads. And finally, the last one, the BCF Horizon extension. Essentially, that's what today's focus would be. We provide the Horizon extension to provide key things for the tenant. First thing is tenant-driven troubleshooting. Essentially, the test path what we have on BCF, we have given the same functionality to the OpenStack tenant right from the OpenStack dashboard. And we have a heat template for faster deployment of application. Then most important thing for today's demo is layer 4 to 7 service insertion using our policy configuration, which you can do on OpenStack dashboard. So real quick on the deployment model, essentially it could be layer 4 to 7 services could be deployed at the edge of the network, or it could be deployed at the for the east-west traffic between the tiers, web tier and app tier and DB tier. So we support both the models. For today's demo, I'll be demonstrating the tenant edge layer 4 to 7 service using our Horizon extension and Palo Alto Networks next generation firewall. Now let's look at the deployment workflow. As I was telling earlier, the OpenStack is more of a self-service model. How does the deployment workflow look like for application topology, and what value we bring in through our joint solution? First thing first, the tenant logs into the OpenStack dashboard and creates the application topology, which essentially consists of network, routers, and the VM. I have a 3-tier app deployed for this particular demo. At this point, as a tenant, for internal traffic, intra-tenant routing, the logical router is used, which is implemented on big cloud fabric virtual switches. Now, if he needs to connect to the internet or external world, he has two options. The first option is connect logical router directly to the provider network, in which case you would not have a firewall in your application topology. Essentially, you will be dependent on data center edge firewall to protect your application from external or internal threats. Now, the second option which we plan to demo is having firewall within the application topology. In this case, tenant manages, provisions, configures the firewall. In this case, Palo Alto Networks next generation firewall, it protects your application from external and internal threats. You just deploy a Palo Alto Networks virtual machine with one interface in the trusted network, which is connected to the logical router, and other one connected to the untrusted interface, the provider network created by OpenStack admin. Then finally, the third the step here is, which is a key workflow in this particular use case, essentially to redirect the traffic to the firewall. Essentially, the tenant would define a service insertion policy. That's what we are going to see in the demo, because of which the traffic coming from the workload would be redirected to the next generation firewall. Then the firewall would do the necessary firewalling based on the policy defined by the tenant. Again, the tenant does all the things here: application topology, managing the firewall, and creating the service insertion policy. Everything under the hood is taken care by our OpenStack plugin, which enables layer 2, layer 3 networking and service insertion policy for the tenant. This is just a visual representation of how it maps to physical topology on the right. When the network gets created, BCF creates a segment. When VM gets spawned on the Nova nodes, we just connect those to the virtual switches. Then when you deploy the firewall, again, we would do the same thing and connect it to the virtual switch and provide the external connectivity for all the workloads. So with that, let me walk you through the demo. So this is the OpenStack setup. I'm logging in as a blue tenant. And this is the application topology with the 3-tier app. And this is the logical router which interconnects this web app and VSPHERE, which does the routing for internal traffic. Then I have a Palo Alto Networks next generation firewall, which connects to the external network on one leg. Other leg is connected to the internal firewall trusted interface. These are the IP addresses. This is BCF controller, single pane of glass for both physical and virtual networking. And this is just a graphical representation of the application topology right on the BCF controller. You can switch to the tabular configuration page. Again, these are 4 segments with the gateway IP addresses configured. These are all dynamically created through our Neutron integration as and when the tenant creates the application topology. The main thing for today's demo is the policy list, which we would use to redirect the traffic to the firewall. By default, it is a permit any. Essentially, all the traffic is routed by the logical router, which is implemented on virtual switch based on what route it has. Let's manipulate this policy list to redirect the traffic and also add some of the additional policy entries and see how it updates. Before that, let's log into one of the virtual machines we hosted, Web1, and this is the IP address 10.141.7. Let's ping to the local VMs, app, and DB. Everything goes through. Only the external ping is not working because we do not have a route or a policy to redirect the traffic. Again, let's do HTTP request to Google. Again, it doesn't go through. Again, there is no route or policy in place. So this is the Horizon extension I was talking earlier. This is one of the enhancements we have. We have 3 main functionality. First one is the reachability test. Essentially, tenant can run some reachability test just like test path on BCF controller. Then we have a template to enable application deployment. Then we have router policies and router policy grid and router policies. This is where we add or change, modify the router policies to permit, deny, as well as do a layer 4 to 7 service insertion. Before really adding a service insertion policy, let's go to the Palo Alto Networks web interface, which is again managed by the tenant. These are the 2 interfaces on Palo Alto Networks firewall. And I have defined the policy. This is the first policy, which is a NAT policy. So essentially, what it does is essentially all the traffic coming from the blue tenant would be NATed with the IP which is given to the untrusted interface here. 10.2.17.19 is the IP address used on that particular interface. Then I also have a security policy. Essentially, that is the main policy which will be used to protect your application. I have defined 2 policies here. First one essentially allows DNS and ping, which is required for your application. And also for this demo, I have enabled the policy to enable only the Google HTTP request, whereas the second policy just denies everything else, including HTTP request on any other site. This is just a sample configuration, but you can have more sophisticated the policy based on application ID, URL, or any signature based or anything which Palo Alto Networks next generation firewall supports, as Sai alluded in his presentation. And Palo Alto Networks also has the way you monitor the traffic going through it. Essentially, monitor tab would provide you the traffic hitting the firewall and the policy. Currently, there is no traffic because we don't have service insertion policy yet. That's why it's shown blank here. We'll insert a policy and see how it changes here. So to add a service insertion policy, just click on Add Router Policy. Essentially, you would give the source subnet. In this case, I would give a blue tenant subnet here, 10.100.0.0/16. I'm using this CIDR block for blue tenant. Then I would give any as a destination. And you have option to do permit, deny based on your need. For the layer 4 to 7 service insertion, you do permit and provide the IP address of the services. In this case, Palo Alto Networks Firewall internal interface IP 44.3. So this immediately gets programmed on the big cloud fabric through our integration. Essentially, as you see, it got updated. Earlier, we had only permit any. Now we have another policy entry in place to redirect the policy traffic to the firewall. So you can delete the policies. You can add more policy entries right from here. It's again the tenant-driven. Now let's it reflects right on the VCF controller as soon as you do it from the OpenStack dashboard. Then let's start the traffic again. Now I can get through the Google, get through the thing through external IP, internal IP. This is again the Google HTTP request going through fine. Now let's do a HTTP request to bing.com. This is unsuccessful because we have a policy in place. As you see on the PAN log, Palo Alto Networks Firewall log, you can see that it got rejected because of the policy in place. You can also see the policy log on VCF controller through our policy log, which identifies the traffic coming into the VCF fabric right here. So just to summarize, we provide as a joint solution a self-service model for the OpenStack deployment. Essentially, it's all tenant-driven workflow. VCF config automated as and when the tenant deploys application and provide a policy to do a layer 4 to 7 service insertion. With that, I'll hand it over to Bala.
Thank you, Ganapati. Thank you, Arkady, and thank you, Sai. That was a great presentation. So let's quickly wrap this up, given that we are approaching our time limit here. So we make it easy for you to get started with Big Switch solutions. There are a number of resources you can download or watch that will give a tour of our products. And in your handout, you'll find live links you can click to access any of these resources listed here. And I want to specifically point out two things. The BSN Labs. With BSN Labs, you can experience Big Switch Networks open networking SDN solutions firsthand from the comfort of your PC. We believe that there's no better way to learn about a product or technology than to actually take it for a test drive. For a free online real-time access to our SDN Fabric products, please visit labs.bigswitch.com or download the handout which is given to you in the dashboard. And we also have a starter kit, Big Cloud Fabric starter kit, which includes the switching hardware, software, support, and cables all ready to deploy. So it really makes it easy for you to implement your very first SDN-style data center pod. So if you need more information on that, you have a detailed brochure online which you can use. So past webinars, including this one, will be posted online, and you can get to those by clicking one of the green buttons on the home page. There is the upcoming webinar is on October 26th, Wednesday at 10 a.m. Please mark your calendars. It is going to be on migrating applications to SDN Fabrics in Brownfield Data Center. Watch your emails for the registration details, or visit our website at bigswitch.com/webinars. That concludes our presentation for today. But if something we discussed here piqued your interest or you'd like to know more, just head on over to our website, www.bigswitch.com. Thank you and have a great rest of your day.